We're back. Super excited to be starting. And we will be starting Wednesday. Monday we're going to have a house retreat, and Wednesday we're going to hit the ground running. For those of you who do not know me, I am Mr. Weeks, and I will be your geometry instructor this year. Most of you have had me for logic, and one of the questions you may be asking is, why this? So, why this? Why the progression here? Why don't we go Algebra 1 to Geometry, then Trig Pre-Calc? Doesn't it make more sense to do it this way? And they're really, this way is fine, but we at FCA choose to do it this way. Algebra 1, Geometry, Algebra 2, then Trig Pre-Calc. And one of the reasons is this. There's this one right here. Logic. Okay? Geometry does a great job of kind of building upon what you have learned in logic. So that's one of the reasons. And then the progression here, this is Algebra 2 is a bit more abstract. It's going to take everything you learned in Algebra 1 and build upon it, of course, but it's a bit more abstract. If students struggle in this, then it gives them a little bit of relief. However, there's not a complete relief. There's a lot of algebra in geometry, so don't think that you're going to break from algebra in geometry. There's a significant amount of algebra in geometry. But what is really the point? The point about geometry here is to help us with our spatial sense. Here's an example of what geometry has helped me in life. Okay, so I've drawn a crudely drawn, let's say you're helping a buddy move, okay? And here's a crudely drawn U-Haul truck, and I wanted to help them move, and so one of the things that's helped is spatial sense. Is how do I get these big old objects, these bikes and everything? Look at my angles of those are all wrong drawn. I want to get a dresser in there, all right, and I'm trying to fit that thing in there along with several bikes. I'm gonna throw up here or something like that. So having good spatial sense is really a lifelong skill. For soccer, as a soccer coach, I'm measuring the lines, and I need this. Okay, so this is called a 3, 4, 5 triangle. All right, so if I measure 3 feet this way and 4 feet this way, and this is called the hypotenuse here. If that's 5 feet, that creates a right triangle. So for a soccer field, if I'm here at the corner and I measure back here and I'm painting this, I create a right. I know my corners are square. All right, because we don't want to have a trapezoid when we're playing on a soccer field. All kinds of three-dimensional shapes and two-dimensional. We spend a lot of time in two-dimensional space, and then towards the end we move towards three-dimensional space. There's a lot of rules, there's a lot of postulates, and knowing little tricks. For example, like this. This is just a mathematical trick that we use. It's not like, it's based off a formula called the Pythagorean theorem, but you learn that as you go. It's not all thrust to you at one time. Okay, we build upon it. And one of the first things we build upon is that logic. Okay, so we might have a structure like this, wanting to find the surface area of a pyramid. Okay, we don't know whether the base here is it square, is it like the pyramids Giza. In this case, it's going to be a trigonal base, and I can kind of draw that in and represented that with a dashed line back here. Let's say I had another figure. I wanted to draw something like this, and this is going to be a pyramid that's upside down, but it's inside something. So just kind of a rough sketch here. If I say it's called a hexagonal pyramid, and let's say this was cut out inside this cylinder, and I wanted to know the surface area. Well, total surface area would be the outside. There's a base down here. There's this little bit here. Got to count all this little sides, and okay. And then I forgot to draw this part in. Okay, we could draw that in solid. Okay, all right. And so there's this side, this side, this side, and the back side we can't see. So three-dimensional object represents 2D space here, and all of this is, the idea of using geometry of calculating the surface area. Now this one here is kind of challenging, and we won't do this till the end of the semester, but you'll learn about how to find the area of just a hexagon, and then how do you find the area of just a circle, and things like that, and they build upon that, or perimeter of this hexagon, and what's called the circumference of a circle. And again, everything builds, and we don't do it all this at the very end, or in the very beginning, we do it at the very end. So I'm excited. I hope you're excited to learn more about spatial sense and applying your algebra skills, and hopefully something a bit more not as abstract, but sometimes a little bit more concrete. And so yeah, I very much look forward to seeing you in class on Wednesday and house retreat on Monday. So have a blessed day, and see you later. Bye.